I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on the radiation pattern measurement. So, the antenna measurement need is to ensure the antenna meets the given specifications and to characterize the antenna. And there are various parameter measurements are available. One is we can measure gain and we can measure bandwidth, radiation pattern, beam width, impedance, etc. And now we will discuss the very important measurement of an antenna, a very important parameter also, the radiation pattern measurement. So because for an antenna, the radiation pattern is very important because it shows in which direction the antenna is radiating. So which is the most requirement if you take any antenna. And for radiation pattern measurement, we always use the antenna in for drawing the radiation pattern. We always kept the antenna in a spherical coordinate system. So in a spherical coordinate system, at the center of the antenna we kept, and we have x and y z coordinates. We have three parameters in a spherical coordinate called radius r, radius of the sphere, and theta is the elevation angle, phi is the azimuth angle. So this is the picture of the graphical representation of the spherical coordinate system. And we know the radiation pattern is the graph which shows the radiation of an antenna either radiated or received in a particular direction with respect to the direction. So from the radiation pattern we can understand that in which direction the antenna radiates more and in which direction the antenna radiates less. And the radiation pattern means the field strength at fixed distance from the antenna as a function of the direction. And use spherical coordinate xy horizontal plane and xz vertical plane. And considering the antenna type is horizontal antenna and vertical antenna. For horizontal antenna, the plane pattern is called E-plane pattern, and in E-plane pattern we have taken the plane as xy plane, and theta is equal to 90 degree, phi will vary. And in H-plane pattern we take xz plane and theta will vary here, and phi is equal to 0. And for vertical antenna is measured in xz plane. Here theta is vary and phi is equal to 0, and in xy plane theta equal to 90 degree and phi is vary. And horizontal antennas used for the earth to earth communication. Vertical antennas are used for the earth and also the space. And this diagram shows the measurement setup of antenna radiation pattern measurement. At the center side, left side, we have a transmitter or oscillator with RF cable, and at the end of the RF cable we have an antenna, transmitting antenna, which is called as a primary antenna. And in the right hand side we have an indicator and also a receiver, antenna drive units, and there is a supporting shaft. On the supporting shaft the secondary antenna, that is the antenna under test, is kept. So the primary antenna is constantly transmitting, the secondary antenna is rotated, so that we have antenna drive units rotated by 360 degree, and at each and every particular angles, step angles, we are measuring the radiation. And after getting all the radiations measured from 0 degree to 360 degree by the use of receiving antenna, if we draw the graph on a polar plot, we get the radiation pattern of the antenna. So this is the method of calculating the radiation pattern of a given antenna. So here the antenna under test can be at the secondary, can be at the right hand side as a secondary antenna, or we can also use the antenna under test at the left side as a primary antenna, and the secondary antenna may vary. So according to the reciprocity theorem of antenna, if any antenna is kept at transmitting side and also at the receiving side, its property must be same, and excluding the losses. And in the measurement of radiation pattern, we have a minimum distance requirement. So in between the transmitting and receiving antenna there should be a distance r. It must be equal to 2d squared by lambda. Here d is the distance of the receiving antenna aperture, and the lambda is the wavelength at the frequency of operation. So this lambda is calculated from the formula c by f, where c is the velocity of light in free space, f is the antenna frequency or the resonant frequency where the antenna is operating, and also the uniform requirement is also available. So primary antenna to secondary antenna we have the same space and with the distance r is equal to 2d squared by lambda. The height is same, we have to make the height is same, and there are two type of rays are available. One is the direct rays, which is directly from the transmitting antenna to receiving antenna, and another one is indirect rays. So the indirect rays are obtained from the transmitting antenna and reaches the ground. From the ground it is reflected back and reaches to the receiving antenna. So these are the two type of rays. And the secondary antenna, that is the antenna under test, the total antenna radiation is calculated by the adding of direct rays and the secondary rays. Here the distance must be made equal to r, and r should be greater than 2d squared by lambda. There should not be no interference in between the paths, that is line of sight, and they mount the antenna on a tall building. So this is nothing but uniform requirement of the radiation pattern measurement. So assessment question. So this is the diagram. We have to explain the concept in details. So there is a primary antenna and a secondary antenna for radiation pattern measurement, and there are two rays, direct rays and indirect rays. The total radiation is the addition of these two rays, and measuring the radiation at the receiving side, that is the antenna under test. We take if we plot the polar graph, we get the total radiation pattern, and here the antenna under test may be used as a transmitting antenna and also the receiving antenna. So in both ways we can take measurements. So this is about a very important measurement of antenna parameter, radiation pattern measurement. Thank you.